Today we're going to be talking about slope, and recall that slope really means the rate of change. So when we're talking about slope, we're talking about the rate of change. We're going to look at finding slope from a graph, from 2 points, and also from a table. From a graph, the easiest way to look at slope is as rise over run. If you have a few points or on a line, kind of like this, try to draw it as perfectly as I can, and you want to find your slope, the easiest thing to do is kind of try to make marks on some places that are at intersection points as best as possible. And then you want to count from one point to another. What is the rise and what's the run? So I'm going to kind of go from this point to this point. It looks like it's going up 3 and over 2. Again, from this point to this point, it's going up 3 and over 2. So my rise is 3 and my run is 2, which makes my slope 3/2. You could call that 1.5, but 3/2 is a common way to write it. If your line was going down left to right instead, you would say it was a negative slope, like negative 3/2. Okay? If you are given two ordered pairs, the easiest thing to do is use the slope formula. The slope formula looks complicated. It says m, which stands for slope, equals y sub 2 minus y sub 1, all divided by x sub 2 minus x sub 1. But this really just means the same thing. We are subtracting our y's on the top and subtracting our x's on the bottom to find rise over run. So for this to be useful, you need to make sure you know which is x and which is y in an ordered pair. So above, negative 2 is x, 4 is y, 3 is x, negative 6 is y. And because negative 2, 4 is my first ordered pair, we'd usually call that x sub 1 and y sub 1. And 3 would be x sub 2, and negative 6 would be y sub 2. So when we're going to use this formula, you're just going to subtract. So on top, you subtract your y's. You take your second y, negative 6, and subtract your first y, 4. In the denominator, we're going to take our second x, which is 3, and subtract our first x, which is negative 2. And then you just solve this problem. So negative 6 minus 4 is negative 10. 3 minus negative 2, that's the same thing as 3 plus 2, that's 5. So my slope is negative 10 over 5. Negative 10 fifths equals negative 2. So it's customary to say our slope equals negative 2. Okay, oops, the negative's kind of disappearing. Okay, and then the last common way that we'll have to find slope is by looking at a tail. Again, you're still doing rise over run. It's very common when you look at a table to think of slope as change in y divided by change in x. So let's fill out some values in the table. We've done this quite a bit in class, but just as a refresher. So if we call some ordered pairs, let's say 5, 20, and then 7, 12, 9, 4, 11, negative 4, and 13, negative 12. Okay, I'm going to look for the change in y, I'm going to look for the change in x, and I'm going to start dividing these. So my change in y, to go from 20 to 12, it goes down by 8. 12 to 4, it also goes down by 8. 4 to negative 4, it also goes down by 8. Negative 4 to negative 12, it also goes down by 8. So I'm going to say negative 8 each time. For my change in x, from 5 to 7, it goes up 2. And 7 to 9 also up 2, and this continues to go up 2. This is convenient because it's the exact same numbers every time. It's going to definitely make this linear. So I'm going to take any one of these changes in y's and divide it by the corresponding change in x. So negative 8 divided by 2, my slope equals negative 4. So if we filled in the gaps, this would say we're going down 4 every time. Okay, this is just some basics of slopes. Hopefully you can use this to help you out in the future.